Hi everyone, I'm Natasha Cabiltes and I'm currently taking up Applied Economics, major in Financial Economics and Accountancy. Today I will be talking about simple interest, compound interest, and annuity. So first, what is interest? Interest is basically the cost of borrowing somebody else's money. Most commonly, interests are applied in investments and debts where one party is the lender of money and the other is a borrower. The lender charges the borrower a certain amount of money based on the amount the borrower borrows from the lender, which is also called the interest. So the interest has two types, which are simple interest and compound interest. So what is the main difference between the two? The main difference between simple interest and compound interest is that simple interest depends on the principal amount of a loan or deposit, while compound interest, on the other hand, is based on the principal amount and the interest that accumulates on it in every period. So, first, let's try to solve some problems on simple interest. But before we do that, we have to note that simple interest depends on three factors, which is the first principal, the interest rate, and the time of loan. Just to go through, the principal is the original amount of money borrowed. The interest rate is the rate charged by the lender that dictates the interest, and the time of the loan refers to the period the lender borrows money. Some important notes is that interest rates are usually expressed in annums. So it means that the interest rate is expressed as the rate for a year, unless otherwise stated in the problem. So this is important to remember, especially when we're only asked for or given the interest rate per month or the time of our loan is less than a year. So we have to remember to convert it into years. So to get the simple interest, finally, the formula is simply I is equal to principal times rate times time. So next, let's try to look at the sample problem. How much interest is charged when 10,000 pesos is borrowed for 2 years at an interest rate of 3%? A tip when solving problems like this is to have the template I am about to discuss. First, we have to write the given numbers in the problem. For this problem, the principal is given, so P is equal to 10,000. The time of the loan is also given, so we have to list T is equal to 2, and the interest rate is given, so I is equal to 0.03. Next, we have to identify what is being asked in the problem. So for this problem, it is looking for the interest, so I is equal to question mark. Next, we have to show our solution by writing down the formula first. As mentioned, to get the interest, the formula is equal to I is equal to PRT. Then we have to input the given values into the equation, so 10,000 times 0.03 times 2, which gives us an interest of 600. The final answer is the interest charge is 600 pesos. Next, we can go to looking for the maturity value or the future value, which is basically the sum of the principal and the interest earned, which gives us F is equal to P principal plus I interest. But we can actually solve for the maturity value without getting the interest by manipulating this equation. Since F is equal to P plus I, and we know that I is equal to PRT, we can substitute that I into the equation. So F is equal to P plus PRT. We can factor out P, which gives us a final equation of F is equal to P times 1 plus RT. For these topics, it is important to have the skill of manipulating equations so we can solve for other missing variables even if we only know one equation. So for example, the problem is looking for the time of loan. We can simply manipulate this equation, the F is equal to P times 1 plus RT, by isolating T, and we will get T is equal to F minus P over PR. Next, let's try to solve a problem about future value by going back to the previous question. So, what is the future value when 10,000 pesos is borrowed for 2 years at an interest rate of 3%? From the previous problem, we solved that the interest rate is 600 pesos. So, which gives us a maturity value of 10,600 pesos. We can check our answer by using the second formula, the F is equal to P times 1 plus RT. We have to input the values, which gives us a same answer of 10,600 pesos. Now that we've learned about simple interest, it is now time to go to compound interest. As per definition, compound interest is interest that is computed on the sum of the original principal of a deposit or a loan and the interest accumulated. Compound interest can be compounded once, twice, or several times a year. By compounding, this means how many times interest is computed in a year. So for us, what we usually encounter in problems in this subject is compounded annually, which means one time a year only, semi-annually, which means twice a year, or quarterly, which is four times a year. Sometimes we also encounter monthly compounding, which is 12 times a year. We have to note that one conversion period is equivalent to 1 year. So next, for compound interest, let us learn about the variables affecting compound interest. First is the frequency of conversion, denoted by M, which is the number of times interest is computed in a year. Next, the number of years of the term for compound interest is denoted by T. So, the total number of conversion periods for the entire term is denoted by N, which is given by the product of time and the frequency of conversion. Next important thing is we have to compute for the interest rate per period or the interest rate every time we compound it. The variables needed here are the nominal rate, denoted by J, and to get the interest rate per period given by I, we simply divide the nominal rate by the frequency of conversion M. Now that we have understood these variables, we can now solve for compound amounts. The formula to find the future value of a compound interest is given by F is equal to P times 1 plus I raised to N. Now we can look at this sample problem. If Mrs. Yalong invested 12,900 pesos for 4 years in a bank that pays 3% compounded semi-annually, how much will she receive after 4 years? By following the template I mentioned earlier, let us first identify the given values in this problem. First, the principal is given, so we list down P is equal to 12,900. The term of the loan is given, so T is equal to 4 years, and the frequency of conversion M is semi-annual, so we list M is equal to 2. The nominal rate J is equal to 0.03. Now we need to find the compound amount F. What will our solution be? First, we know that the formula for finding the compound amount is F is equal to P times 1 plus I raised to N. But then we don't have I and N. So first, we can solve for I given the variables we listed earlier, which is I is equal to J over M. So I is equal to 0.015. And then we can also solve for N. So N is equal to Tm. So 4 times 2, N is equal to 8. We can now input this into the formula. So F is equal to 12,900 times 1 plus 0.015 raised to 8, which will give us a compound amount of 14,531.75. So similarly, when we are then asked to solve for other variables in the problem already, like the compound interest or the time of loan or the interest rate, we can just remember that F is equal to P times 1 plus I raised to N, and we can manipulate the equation by isolating the variable we want to find. Alright, I guess we now know better and understand more about simple interest and compound interest. Our last topic for today is annuity, and I think that a lot of people confuse compound interest and annuity, so let me break it down for you. The main difference between compound interest and annuity is that compound interest assumes that we put money into the account once and we let it sit there earning interest, while annuity, on the other hand, assumes that we put money in the account on a regular schedule and we let it sit there earning interest. If a tip during the finals when all the lessons are already mixed up is that if you see the term regular deposit or pays this amount every month or every quarter, then it is annuity. If there are regular payments, then it is annuity. Now, let us talk about annuities further and their classifications. We have two types of annuities, annuity certain and contingent annuity. Annuity certain is the type of annuity where payments begin and end at definite times. So examples of this are usually installment plans where we buy expensive things like appliances, condominiums, etc. And contingent annuity, on the other hand, is a type of annuity where there is a sequence of periodic payments in which the payments extend over an indeterminate length of time. Examples of contingent annuities are life insurances because the payment ends at the death of the insured person and we can't really say when a person will die. So basically, for annuity certain, we know when we begin and end our payments. But for contingent annuity, we don't know when we begin and end the payments. But for now, we will only discuss about annuity certains. The types of annuities we will discuss today about annuity certains are divided into two, which is ordinary annuity and annuity due. The difference between these two is not that big actually. Ordinary annuities are annuities where the term starts at once and ends on the last payment periods. The periodic payment is made at the end of each period. Annuity due is basically the opposite of ordinary annuity. The periodic payment are made at the beginning of payment intervals, which means that the payment already occurs immediately. And the last payment is made one payment interval before the term ends. So the formula for present values of these two annuities are not that different either. But first, we have to recall the variables we need to understand this formula. The formula for calculating the present value of an ordinary annuity is given by A is equal to R times 1 minus 1 plus I raised to negative n over I, where A is the present value of an ordinary annuity, then R is the periodic payment of the annuity, I is the interest rate given per period, and n is the total number of payments or periods. Let's now compare this to the formula for the present value of an annuity due, which is given by A with two dots on top is equal to R times 1 minus 1 plus I raised to negative n over I times 1 plus I. As you can see here, the only difference is that we use the formula for ordinary annuity. So we can revise this formula into A with two dots on top is equal to A times 1 plus I. The only difference is that we multiplied 1 plus I. Why is this so? Remember that for annuity due, we make the payments immediately. So we have one extra payment as compared to the ordinary annuity. So we have to account for that extra payment. As we can see, the difference is merely the interest earned in the last compounding period. Because payments of an ordinary annuity are made at the end of the period, the last payment earns no interest while the last payment of an annuity due earns interest during the last compounding period. Next, to find the future value or how much the ordinary annuity earns at the end of the term, the formula is simply S is equal to R times 1 plus I raised to n minus 1 over I. From this, we could also derive the future value of an annuity due. Recall that the only difference of ordinary annuity and annuity due is that there's an extra interest earned because we made the payment earlier. So the future value of an annuity is denoted by S is equal to S times 1 plus I. Note, now I think that we are ready to solve some problems. So if the prevailing worth of money is 12% interest compounded monthly, find the present value and the amount of annuity of 2,000 pesos payable monthly for 10 years. Following the template I've mentioned earlier, we first identify the variables provided in the problem. Usually when the problem is silent, like it doesn't state when the payments are made, we assume that it is an ordinary annuity. Given our denominator rate J is equal to 0.12, frequency of conversion which is monthly, so M is equal to 12, and periodic payment R is equal to 2,000 and the term of the loan T is equal to 10. We are required to solve for the present value A and future value S. For a solution, we first compute for N and I because they are the variables needed in the formula. So N is equal to T times N. so n is equal to 120. I is denoted by j over m, so I is equal to 0.01. We now substitute the values into the equation. First, we solve for the present value of a. A is equal to r times 1 minus 1 plus I raised to negative n over I. So inputting the values, we get A is equal to 139,401.04. The present value of the annuity is 139,401.04. Now we solve for the future value S. Inputting the values, we get S is equal to 460,077.38, and the future value of this ordinary annuity is 460,077.38. Now, we can use the same problem, but we can change the equal payments to the start of the period, which makes it an annuity due. We have the same given and requirements, but recall that in an annuity due, we basically just have to multiply the value we got from the ordinary annuity to 1 plus the interest rate. So to get the present value, if this were an annuity due, we obtain the value we got from the ordinary annuity, which is 139,401.04, and we multiply it to 1 plus the interest rate, which is equal to 1.01. So we have the present value of the annuity due is 140,795.05. And for the future value, we get the future value from the ordinary annuity and multiply it to 1.01, which gives us a future value of the annuity due of 464,678.15. So basically, that's it for a simple refresher about interest and annuities. But before I end this discussion, I think that it would be helpful to share that there is actually an Excel formula to calculate future values and present values of annuities. So to get the present value, we just have to go to the formula bar in Excel and type equals PV and a parenthesis, and this will show up. So we have to fill in what is required. And for future values, we have to just type equals FB and input these given variables. Let me discuss the variables we see in the Excel formula. First is the rate, which is the interest rate in decimal form. So this is already the I is equal to J over M. Next is the number of periods, which is the number of payment periods. So in the formula, this is N is equal to TM. Next is the payment, the amount of periodic payments when they are the same. This is the R in the formula. And it is important to note that we have to enter the payment as a negative number if we are going to pay for it. If we are receiving the payment, it is inputted as a positive number. Next is the future value, which is the value of the investment at the end of the term. Present value, the value of the investment today, and type, it is whether the payment is made at the beginning of the period or the end of the period. So you input 0 if it is made at the end of the period. So this is the ordinary annuity if your annuity is ordinary annuity. One is the payment is made at the beginning of the period. So if your annuity is annuity due, you input 1. So we can finally solve through Excel our problems about annuity earlier. The problem is if the prevailing worth of money is 12% interest compounded monthly, find the present value of 2,000 pesos payable monthly for 10 years. So we're looking for the present value, and you basically just have to input equals PV into the formula bar and fill in the variables. So the rate is 12% over 120, which gives us 0.01 because I is equal to J over M. Number of periods, 10 times 12 because it is compounded monthly, so 120. And since we are paying 2,000 pesos, we have to put negative 2,000. And since we don't have the future value, we basically leave it blank and type, since this is an ordinary annuity, we input 0. So when you input this into the Excel, this answer will show up, which is basically the same answer when we were solving for the ordinary annuity using the formula given. Next is the future value of an annuity due. So if the prevailing worth of money is 12% interest compounded monthly, find the future value of 2,000 payable monthly for 10 years made at the beginning of the period. So you input equals FB and fill in these variables. So rate is the same, 0.01. Number of periods is 120. The payment is negative 2,000 and present value is blank. And the type is 1 because it is an annuity due. So we get the same answer of 464,678.15. You can try this out in Excel if you want. Basically, this is it for my discussion today. But a fun fact, aside from this, we can actually solve for values of annuities using a basic calculator. But due to time constraints, I will only teach how to do it in Excel because this is more helpful for us. The tip here is to really master and understand how annuities work and really understand the variables in the formula. So we can just manipulate the formula around without even memorizing all the formula given. So if you want to learn more about annuities and tips and tricks in computing them, or if you have any further clarifications, please do not hesitate to message me. Once again, I am Natasha Cabiltes and I hope this video has helped you prepare better for your upcoming finals. Thank you and good luck.